Hello everyone, my name is Nael. I'm a computational journalist and the creator of Code Like a Journalist, a free online open source course about data analysis and data visualization with TypeScript. Today's lesson is about fetching data. We are going to learn how to fetch and download data from the web. But first, if you want to know when new lessons are available, subscribe to the newsletter, give a star to the GitHub repository, or subscribe to this YouTube channel. So I have VS Code open. Let's get started. We can open a new folder to create a new project. And let's create a new file called main and deno.json. We can run this by doing deno run one check. Deno run watch check main.ts. Go, we're ready. So let's start by fetching a JSON file. There's a JSON file that I put on GitHub specifically for this lesson. It looks like this. You can see that it's an array of objects with date and temperature. These are the daily temperatures in Montreal, and we are going to fetch it. To fetch something with Deno, you can use the fetch function. It's available globally, and it looks like this. So here what we're doing, we're creating a variable response, and in this variable, we want to put the result of a fetch call. We want to wait for the response, and fetch needs a parameter, which is an argument, which is a URL, and it's the URL of the JSON file that I just showed you. So response, await, fetch. We need await here because fetch is asynchronous. It fetches data over the internet, but we don't know how long it's going to take. So just to make sure that we wait for the full response to be on our side, we say, hey, Deno, I want you to await for the response of the fetch call. And below, we log the response. But we have a security warning, right? If you save that file, this code example, you'll have a warning because you'll see that, oh, Deno requests net access to raw GitHub user content.com. It's trying to access something over the internet. It's the same thing that we had with writing and reading files. We can allow it just once by doing Y and enter. Or if we want, we can use the flag. So deno run watch check main.ts. We can add a flag here, allow net, and this will allow requests over the internet. Again, this is a great feature of Deno. When you're running some code that you didn't write, that maybe you downloaded over the internet or that someone sent you, it could be quite terrible if this person tries to steal your data and then send it over the internet. So we have this great feature when you're running unknown code for the first time. Don't allow anything. Check what Deno is seeing, and if everything is safe, then you can add the flags like allow write, allow read, and allow net. We don't want to run this, which starts to be quite long every time. So we can also do deno run watch check and use the shortcut -a to say, hey, you can do whatever you want, main.ts. I know you, it's fine. So this works. You can see that there's a lot of stuff in the response, right? This is the response that we are logging. There's a lot of stuff because to actually transfer data from your computer to GitHub servers and to GitHub servers to answer you with the data that you're requesting, well, your computer and the servers need a lot of information. But in our case, the only thing that we are really interested in is the data, right? The JSON data. And so to do that, you can extract the data from the response with await response.json, like this. And we can log the data now. So response here is also an async function. The reason why it's async is that we don't know how big response is. And maybe in some cases, you don't want to wait for all of the response to be converted to a JSON before doing something else. In our case, we want to await for each step. We want to wait for the full response. And once we have the response, we want to wait for the full response to extract and parse the JSON data and to put it inside the data variable. So let me show you the result. We now are logging data, and we have the data exactly as expected. We just fetched data over the internet. It's a JSON file, so we are also parsing it as a JSON, and now it's ready to be used. So we can select just the first element, and if we could use just the first temperature. It's ready to be used. Now, this is great. We are able to work with that, but it would be great to actually download this data on our computer. And to do that, you can write a file. So here we are writing a text file. Let's say that we want to save this JSON file as a temp.json. And now we can stringify again data to write it, right? This comes, we've seen that in the previous lesson about writing and reading files. So here we are fetching the data, then we are parsing it, extracting the data from the response, because there is a lot of stuff in the response. And then we are using the data to write it into a file with Deno write text file. We are writing temp.json with a stringified version of our array of objects. So now if you check, you can see that you have temperature.json over here. It works. You just fetched and saved data. You downloaded data. Easy. So this is JSON, but you won't always be fetching JSON data. Another very common use case is fetching CSV files. It's pretty straightforward as well. On GitHub, you'll find a CSV file that I created for this lesson. It's the same data. So you can see that you have date and temperature. The first row, it's the columns headers, and then you have the data. It's a CSV, so you have the first date, and then it's separated by a comma, and then the temperature. So pretty simple data. Now, the difference with the JSON file, so first we can change the URL. I'm going to grab everything. Go. So we have a different URL, so we update the fetch call. But now instead of doing .json, we do .text. It's not a JSON file anymore. CSV is just text. So we extract the response, we extract the data as text. If you do a console log data, you'll see that the data is just raw text. And if we want to save it on our computer, we can use deno.write text file again. We can write temp.csv. and now pass our data. When we were writing JSON data, we had to stringify it because a JSON array of objects is not a string, right? It's an array of objects. But here, the response data is just text. It's a CSV. And write text file expects text data. So we can just pass it directly. There is nothing else that we need to do. And if you check temp.json, you can see that, yeah, you downloaded the data on your computer. You fetched it, and then you wrote it on your hard drive. It's available in the folder. If you are on Mac, you can do reveal in Finder, and you'll see that inside your folder, you now have JSON and CSV. Another thing that you might want to do is to fetch the web page of, to fetch the HTML of a web page. In another lesson down the road, we will learn how to do web scraping, how to extract data from web pages, which is a technique that you use very often as a computational journalist. And to do that, you want the actual code of a web page. So here you have another example where we do that with the Code Like a Journalist website. And it's pretty simple. We fetch the page, codelikeajournalist.com/en for the English version, and we do response text to get the HTML, and you can see the HTML here. It's the same thing as the CSV file, except that this page here is not displaying any CSV file data, it's showing an actual web page. So when you do .text, what you are extracting is the HTML that you can see over here. Doctype HTML, and you have all of the HTML code that renders Code Like a Journalist homepage. We are going to use that in another lesson about web scraping. And that's it. This is how you fetch data. So you use the fetch globally available method function, and you pass in a URL of what you want to fetch. Then you await for the response. And depending on what it is, you use .json if it's a JSON file, .text if it's a CSV file or another text format, or just text if you want to extract the HTML code from a web page. And if you want to save this, you can just use Deno write text file. Easy. If you enjoyed this lesson, subscribe to the newsletter, subscribe to the YouTube channel, and add a star to the GitHub repo. See you in the next video.